Okay, ladies and gentlemen, this is a review of similar shapes and basically finding a missing side or two of similar shapes. Okay, so let's take problem 8 from a previous worksheet and follow the purple. Notice that we're trying to find this side x, and x is part of this bigger triangle, right? Now the first word I want to make sure you understand is these are similar because if you notice they have the same shape, okay? We just have one that's bigger than the other. So the thing to understand is with similar shapes, the sides are going to be in a certain ratio, a scale factor, as we like to call it, a scale factor. Okay? So these are terms hopefully you get used to. The idea though with a scale factor is the sides are in a set ratio that you can use to figure out missing pieces from. Okay, let's get to the problem. So follow the red. Does everybody agree that x there matches what in the smaller triangle over here? Hopefully you say it's 9.2. X goes with 9.2, right? Follow the yellow. So notice, what else do I know? I know that 6.4 matches 4.7 as well. So notice that now I can solve and come up with x, correct? And that's what I'm going to do with my calculator. So solving this, I'm going to cross multiply, right? I have 4.7x equals to 6.4 times 9.2. See how I cross multiplied? So 4.7x equals 58.88 once I multiplied 6.4 times 9.2. And hopefully you agree I'm now going to divide by 4.7. Yes, I'm doing this with a calculator just like you should. And I now know that x is 12.52. That means the missing side, this hypotenuse for the bigger right triangle, is 12.52 centimeters. Notice the units are centimeters. Okay, pause the video. That is if you need to. And make sure you understand how I matched up the sides and made proportions and then did some cross multiply. So again, pause the video if you need to. Okay, here's one more problem I wanted to do with you real quick. And I wanted you to notice, first of all, it's a word problem. And the first thing, guys, you must do is do some kind of sketch, write down the information, draw some kind of picture so you can actually see what's going on. You see, I know I have this tree, right? They tell me. So there's my tree. And there's the sun shining down. And of course, there's going to be a shadow made on the ground here, right? And we're told that that shadow is 30 feet long. Okay? And supposedly there's some guy standing nearby. And we know that he is 6 feet tall. And this same sun is shining down at the same angle. Okay? And along the ground here, we know that his shadow is 5 feet long. 5 feet long. Well, let's see here. What color can I use? I'll use purple. Can everybody see? Basically, I have a right triangle here, because after all, trees normally stand straight up, just like the sky stands straight up and makes a right triangle, right? And the angle of the sun, again, is going to be basically the same for both if they're standing close to each other. If they're standing close to each other. So therefore, guys, can we figure out how tall the tree is? And the answer is yes. Let's call that x. So the height of the tree we'll call x. And does everybody agree that x goes with 6, right? just like 30 goes with 5 feet. Now, let's see here. I'll use green now. Again, I took X from the bigger triangle, the tree that is, and I compared it to how tall the guy was, which was 6 feet. And they are what we call corresponding, right? And of course, I took the shadow for the tree, which is 30 feet, and matched it up with the shadow of the guy, which is 5 feet. Now it's just a matter of doing calculations. Hopefully you know that I'm going to do 5 times X and then 6 times 30. Now 6 times 30 is 180. Okay? And now all I have to do is divide by 5. And X comes out to be 36 feet. So now I know the tree is 36 feet tall. Okay? And notice I was able to figure that out without having to actually measure the tree. I could very easily measure the shadow of the tree, right, in real life. Just like I can very easily measure the shadow of the guy. And I know the guy is easy to measure, 6 feet tall. And notice I was able to find that height right there, that tree, without directly measuring. And that's one of the powers of similarity, guys, and using similar shapes and trigonometry and all that other stuff that you're going to learn over the next year or two. So in summary, notice on this one, I had to draw the picture, right? That's how I was able to solve it. Whereas the first one, notice, even though the picture was backwards, were we able to match up the corresponding sides correctly? And hopefully, you agree, you understand what I did. So until next time, guys, bye.